Okay. I'll go and share my screen. Atulya, what you do is you connect from your Skype meeting app. Okay. What is physical mission? Why do we go with physical mission, Divya?
So physical machine is like a machine that you can touch and feel and see.
Okay.
So why do we go with it? Because it's particularly dedicated to a single individual. Like if I'm working on my machine, it's dedicated to me. The CPU, the memory, all the resources are mine. I can use it.
Okay. At the same time, you have a fixed CPU, you have a fixed memory, fixed hard disk, right? Maybe you can add a little bit of memory, you can add some hard disk, but ultimately a single physical machine that you have, and you are restricted to run only that particular operating system. One operating system, uh, one physical machine, and you are restricted to run your workloads on this. So if in case this machine shuts down or maybe having some problem, what happens? There is a single point of failure. We call it as SPOF or SPOF, because you tend to lose all the data or all your application because your physical machine has some problem. Is it clear?
Yeah, yeah.
That was one of the reason why we moved on to another a system that is called virtual machine. Here you will be able to create multiple VMs on your physical machine depending on your system configuration. We were able to achieve maybe a little better high availability. Here we should also think about how to create a cluster. What is a cluster?
A group of computers or servers or uh, a collection of systems basically.
Yeah, group of servers connected by proper network cables, proper network configuration. So that it behaves like a single machine. Single machine. However, if you are trying to access something from outside world, this will be acting like a single machine. This will not be look like multiple machines there. So for that you require a software, cluster software. There are multiple different providers available that can make your system look like a single machine. Okay, we'll move on further. So that is one of the reasons why we never wanted to just go with a physical machine. Instead, virtual machines. Does virtual machine solve every problem?
I don't think so. Not really.
Because
Because virtual machine, again, it is put on, I mean, it is on the existing hardware or it uses the existing system resources. So again, there is a chance of SPOF and running out of resources.
true. Basically, you still have a problem of maintenance and hardware replacement. And sometimes you also feel that it is obsolete, or you probably want to recycle. What happens in this case? You tend to spend a lot of money. You probably end up spending a lot of money to repair or buy new hardware. Correct? Is it clear?
Yeah.
That is why that is why we started using cloud operating system. So cloud operating system is nothing but majorly compute, storage, database. What is the other one? I forgot.
I have so far used only these, so I don't know what's the other one. We have compute, we have storage, we have database, then no idea.
Okay, we'll just stick on to the fourth step. Okay, the other one is networking. So without networking, you can't do anything. So networking is VPC, database is RDS, storage is S3, EBS, computer is EC2. So when we move on to the cloud, we have options to choose uh, cloud services like compute, storage, database, and networking. So without networking, without having a basic networking, it is difficult to work on the cloud. So that is the primary thing for any task that we do. Because even if you look at EC2 instances, it has to be on a particular networking, particular VPC. If you talk about database, it has to be on a VPC. If you talk about storage EBS volume, it can be or it cannot be in a VPC, but ultimately you will end up using VPCs.
If we have to connect to the storage or store something from our system, so then we might need VPC, right? For storage S3 as well.
S3 is a global service. We don't have to really worry about VPC because that's a storage service separately. It is managed by AWS. It is not on the VPC. Say, for example, it is something like your MP3 file storage or YouTube, where you access uh, YouTube videos, right? Like that, S3 buckets can be accessed simply going to the particular URL. You don't need to really worry about which uh, account you belong to, or which region you belong to, or which VPC you belong to. That doesn't matter. It can be accessed directly also, as long as you have the public access for the bucket.
Okay, okay, got it.
So what are the few primary concepts or fundamental things in cloud? One is pay as you go. What does that mean?
So you pay for the services or resources that you have used.
Exactly. You tend to reserve particular system or resource for a particular set of time and run it, reserve, run, and destroy. So only when you reserve, you will be built. When you run this, you will be built. When you destroy, you will not be built. It is as simple as that. And you don't need to worry about latest hardware or latest operating system. Everything is provided to you by cloud provider. You don't need to worry about your operating system, your hardware, or other softwares. So everything is managed by cloud provider. So you don't have the hassle of thinking about, running about, managing about all these things. Correct?
Right. Yeah.
Now again coming back to another explanation. So when we look at okay, here I just want to highlight. Okay, let's go like this. On your physical machine, what exactly you do to keep it running or keep it accessible?
Keep it accessible as in keep the power on, for
Keep the
example.
power. But ultimately, you will have to install some operating system on your server, on your
Yeah, yeah. To use it, yeah, we need operating system.
for that you will definitely require an OS image. It could be a CD, DVD, or drive, pen drive. Then only you can install an operating system and make your laptop available for you, isn't it? Any questions on
Right. No, no question so far.
that? Okay. So mostly it is you have all the list of packages installed, configured, everything is well defined. Right. On a physical machine, if you run an operating system, is it possible to create a snapshot? When I say snapshot, the existing operating system created as a snapshot or maybe created as a backup. Is it possible to create a snapshot from your running operating system on a physical machine?
I don't think it is possible.
From your machine, it is not possible to create a snapshot. Whereas the same problem got resolved when you are running a VM. Because VM allows you to create a snapshot and boot your operating system from the snapshot. So you have the flexibility of running multiple operating systems, also booting different versions of operating systems, and you are able to also move between different systems or different places by putting it into hard drive, putting it into CD or something. You can move it to a different place so that other people can use the same operating system image and boot the server. Okay, the same thing on cloud. It is called as AMI. What is it? What is it called? What is the expansion for AMI?
I don't know what is the expansion for him.
Amazon Machine Image. That is nothing but the machine image provided by Amazon, which is nothing but an operating system which contains all the predefined data for running an operating system. It's a preloaded operating system. It can be Amazon Linux, it can be Ubuntu, Windows, or any other operating system, whatever Amazon can support. Okay. One of the basic uh, okay. Now the question is, say you are buying a smartphone or you are buying a laptop from online or maybe from the store. What are the different features you look at it?
We look at RAM, what's the memory, and um, what is the clarity of the pixel of the images.
Correct. So many different features that you look at it. So many different parameters you look at. Similarly, on cloud, if you want to really look at it, if you want to really choose an operating system, you look at the instance type. Apart from AMI, your operating system image, you look at the instance type and you choose based on your budget and usage or depends on your workload. So that varies from T2, T3, micro, mini, sorry, not mini, micro, small, medium, and large. And you also have extra large, 4x large, like that. You have multiple sizes available. The reason why we have multiple sizes is depending on the workload that you want to run, and depending on the number of services that you want to run it on the system, you need to choose the type of the instance. So it contains storage, memory, CPU. Yeah, three things are major. After that, your compute capacity speed, your processor speed, and things like that, it will come into picture. Okay. What is what is a server? Any answer for this? What is a server?
Server is a program that serves requests from the client.
Yeah, server is a machine or a compute or a computer which is having some resources inside and the services are running to serve the customer. People, when somebody is trying to access something, if it is accessible, that means it is called a server. Say, for example, you want to go and have food in the restaurant. The restaurant is not available for you, or restaurant is closed, right? Do you still think you can go inside and then eat food,
No,
right? That means the server is not running. For server to up and running and accessible, there has to be some service running and it should be accessible to the customer. It should be accessible to the public or it should be accessible via the internet. So that's why we need to have at least one service running on the server or the computer or the EC2 so that people can access to the particular service. For example, you can take anything like Amazon, Flipkart, Make My Trip, any bus booking app, train booking app, anything you call it as, it has to be running. Otherwise, it cannot be accessed. Okay, any questions so far?
no questions so far.
So basically, the flow will be there is a compute that installed with operating system. You run services and then you allow access and it becomes a server so that people can access a particular port, IP address, or a domain. That's why that's when it becomes a server. It is accessible to people where you actually deploy the actual application, right? When we say services, it is nothing but your application that is getting deployed. The whole purpose, the whole and sole purpose of creating a server is to deploy this application onto your instance or compute or your cluster. So we'll talk about cluster in a little while. I think we talked about cluster, right? Initially also we talked about cluster
Yeah, yeah.
where you have multiple machines connected together acting as a single machine, so that you can avoid single point of failure. You can remove single point of failure. When one goes down, the other one picks up the changes and it serves a customer request. Okay, moving on. So to host an app or a website, you need a server. Bus booking app, what you do is you develop an application, test that application, deploy that application, and release that application so the customer can access it and then book their bus tickets. The next thing what you do is you do marketing, sales, so that give some advertisement so that people can people will get to know that there is a particular application or service which is released, which is more cheaper or has more offers. So people start accessing the application. Okay. Any questions so far?
No, so far no questions.
Okay. The next thing that we need to look at is we need to look at how to make it highly available. For example, if one server is going down, how do I make the other server accessible? How do I make sure there are multiple services of my application is running so that it never goes down? And how do I make it highly scalable? That means there is more requests coming in order to maintain the performance of the application. How do I add more servers? How do I add more services? And there is one more terminology called fault tolerant. Say, for example, one service is actually running fine, all of a sudden there is a problem. How do I route the traffic to the other server? That is what is fault tolerant. Highly available, it is availability zone concept. Highly scalable, it's auto scaling feature. Fault tolerant is load balancer. These three concepts are very, very important in terms of cloud. Okay, you can unmute and ask questions, Divya now.
I don't have any questions, but I just wanted like to reinforce what I learned. High availability because maintaining multiple servers in different availability zones, and highly scalable is like can I increase the resources according to my requirement, and fault tolerance is like how I can break a single service into multiple chunk or microservices and like try to distribute it among several servers so that the load is balanced and the single system is not having a overhead. Is that correct?
Yeah, single system not having a overhead, definitely that's a correct answer. Ultimately, using a load balancer so that load can be distributed across different servers.
Okay, got it. Yeah.
Okay, with this, I'll probably stop today's session as people are also having trouble connecting to the call. I'll make sure everybody connects without any trouble from tomorrow. You can probably stop recording for now.